Hello, 7th grade math students. Today we are looking at lesson 112. So lesson 112 deals with the applications of the Pythagorean theorem. So remember, the Pythagorean theorem, just as a refresher, deals with my beautiful drawings of right triangles. Okay, and the Pythagorean theorem says if this is A, this is B, and this is C, that A squared plus B squared equals C squared. And you've been doing some of those problems where you have to use the Pythagorean theorem. That's what we're talking more about today, applications of this theorem or using this theorem. So there's one thing that we should talk about, and that is we have things that are called Pythagorean triplets. So Pythagorean triplets are three numbers that have been proven and tend to be fairly common when it comes to these right triangles and then the A squared, B squared, and C squared. Okay, so what this means is 3 squared plus 4 squared equals 5 squared, which is true. 9 plus 16 does equal 25. So 3, 4, and 5 are what we call a Pythagorean triplet. So are the multiples of 3, 4, and 5. So if I took each of those numbers and multiplied them by 2, I would have a 6, 8, 10. That's a Pythagorean triplet. If I went to these and multiplied them all by 3, I'd have a 9, 12, 15. Again, a Pythagorean triplet. Okay, another Pythagorean triplet is 5, 12, 13. So we call it a 5, 12, 13 right triangle. Okay, meaning 5 squared plus 12 squared equals 13 squared. Also the multiples of this, so 10, 24, 26. That would be a Pythagorean triplet, and other multiples of the 5, 12, 13 as well. So the common ones that we're going to see most often would be a 3, 4, 5 right triangle and 5, 12, 13 right triangle. The thing to remember with these triplets is the longest side of either of these is always going to be the C, the hypotenuse. So the longest side is the hypotenuse. Okay, well, let's put this Pythagorean theorem to use. So here's a problem. It says a 12-foot ladder was leaning against a building. The base of the ladder was 5 feet from the building. So that means the bottom of the ladder was 5 feet away from the building. How high up the side of the building did the ladder reach? Write the answer in feet and inches, rounded to the nearest inch. Okay, so I did one of my fabulous drawings for you. So I have a building here. It's a brick building, as a matter of fact. And I have a ladder that is leaning up against that building. So that ladder, they tell us, is 12 feet long. And the base of that ladder is 5 feet from the building. What it asks us is how high up this building is that ladder reaching? Okay, and I have to round that write it in feet and inches, but rounded to the nearest inch. Now, when I hear rounded to the nearest inch, that makes me think I need to change everything to inches first. So that is what I did. So change this to 144 inches because that's what 12 feet equals. And I changed my 5 feet to 60 inches. Now I can use the Pythagorean theorem. So I'm going to take A squared plus B squared equals C squared. So my A is 60. So 60 squared plus my B, I don't know that, B squared equals 144 squared. Okay, so 60 squared, I can do that one pretty easily. 60 times 60, well, 6 times 6 is 36. There were 2 zeros involved there, so 3,600 plus B squared equals, can't do this one in my head so well, so we will take 144 times 144, 4 times 4, 4 times 4 plus 1, 4 times 1 plus 1, 1 0, 4 times 4, carry a 1, 4 times 4 plus 1, carry a 1, 4 times 1 plus 1, okay, 2 zeros. 1 times 4 is 4. 1 times 4 is 4. 1 times 1 is 1. So I add all those up together. I get a 6 and a 13. 6 plus 7 is 13, plus 4 is 17, carry a 1. 6 plus 4 is 10, carry a 1. Okay, so I get 20736. Okay, so I need to solve for B. Okay, so I need to subtract 3,600 from both sides. Okay, I get B squared equals, okay, I have 6 minus 0 is 6, 3 minus 0 is 3, 7 minus 6 is 1, and then I have 20 minus 3 is 17. So 17,136. Now I'm going to have to take the square root of that, which I can't do in my head. So I'm going to pull out my handy dandy calculator, take 17,136, and I'm going to take the square root, and I get 130.9 da 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 da. But it says I need to round to the nearest inch. So this is in inches here, so I'm going to round that to 131 inches. So B is going to equal, and that's that right here, 131 inches. But the problem asks me to write it in feet and inches. So I'm going to take my 131 and divide by 12. So 12 goes into 13 one time. 1 times 12 is 12. Subtract, bring down. Oops, almost brought down a 0. Bring down a 1. 12 goes into 11. It does not. Okay, so what I have left over, because that would be minus 0, I have 11 left over. So 11 out of 12, well, that would mean 11 inches, because there are 11 inches out of 12 inches. So I have 10 feet, 11 inches, and that is my answer. So that is using the Pythagorean theorem, a squared plus b squared equals c squared, in order to find that missing length. All right, last problem here. It says figure ABCD illustrates a rectangular field 400 feet long. So I went ahead and labeled my 400 feet, and 300 feet wide, and I labeled those. It says the path from A to C is how much shorter than the path from A to B to C? Well, I know from A to B to C, 300 plus 400, that is 700 feet. So I need to find the path from A to C and see how much shorter it is. So how am I going to do that? Well, I'm going to say, hey, I've got a triangle right here. Okay, so with that triangle, I can use the Pythagorean theorem. A squared plus b squared equals c squared. You might have seen a Pythagorean triplet here. Remember our 3, 4, 5 right triangle? Okay, multiply all of those by 100. 300, 400, 500. So this would become 500 feet. If you did not see that Pythagorean triplet, it's okay. You can still do your 300 squared plus 400 squared, and then find the square root of those once you've added them together, and that'll still give you 500 feet. So A to C is 500 feet. A to B to C is 700 feet. How much shorter is this? Well, take your 700 minus your 500, and you would get 200 feet. All right, have a great time working on the applications of the Pythagorean theorem.